The next item here, or function, we are to find the derivative is sine of z squared. This is our function, but you can see that the angle here for our sine is also another function. That would mean this is an example of a composite function where if we're going to take h of z being equivalent to your sine z squared, the outer function, you can treat that as your f of z. You can take its sine of z, just the outer, and this inner here, you can take that as your g of z, which is z squared. So this is actually equivalent to your f of g of z, where the z of your f of z here is the entire g of z itself. And for situations like this, we are going to use here the chain rule, previously discussed as part of the rule on differentiating complex numbers, or this is also known as the rule on differentiating composite functions, because it's a composition, or I mean the composition of one function is another function in itself. We know that this is actually equivalent to this. We are going to treat the first outer function as itself, okay, meaning this is treated as a 1, then multiply it with the derivative of the inner function g of z. If in case that our inner function is also a composite, so we will have another one just like that. So this is equivalent to the derivative of our entire function. This is supposedly sine z. So the derivative of your f of z is actually equivalent to cosine z as derivative of your of sine z. But since our z here is g of z is z squared, this is equivalent to cosine of your z squared. Okay, that is just for the outer. We are treating the inner terms as one identity, meaning let's say it's not just other function, but it's just an arbitrary value there. So we're treating that as z squared in itself, and we get the derivative of the outer. But we are to multiply this with the derivative of the inner. Our g squared here, I mean our g of c is z squared, so the derivative of that is obviously 2z. So we have here times 2z. Just simply rearranging them, because we would like to write with starting with the numerical coefficient 2, and let's say z here before the trigonometric function cosine of z squared. This is already acceptable as the final answer, and this is the derivative of the given sine z squared. Thank you very much for watching.